The nature and structure of the star. Stars are one of the most fascinating objects in the universe, and they play a crucial role in the formation and evolution of galaxies. Stars are massive, luminous spheres of plasma that emit energy in the form of light and other forms of radiation. They are held together by their own gravity and undergo a complex set of physical processes that determine their properties and behavior. One of the most important properties of stars is their mass. Stars can range in mass from less than 0.1 solar masses, the mass of our Sun, to more than 100 solar masses. The mass of a star determines its temperature, luminosity, and lifespan. More massive stars are hotter, brighter, and have shorter lifespans, while less massive stars are cooler, dimmer, and have longer lifespans. Stars are also classified based on their spectral type, which is determined by the temperature of their surface. The spectral type of a star ranges from O, the hottest and most massive, to M, the coolest and least massive. The spectral type of a star provides information about its temperature, luminosity, and chemical composition. The structure of a star is determined by its internal processes, which are driven by nuclear fusion reactions. In the core of a star, hydrogen atoms are fused together to form helium, releasing a tremendous amount of energy in the process. This energy is transported through the interior of the star by convection and radiation, and it is eventually radiated away from the surface. The outer layers of a star are composed of a thin layer of gas called the photosphere, which emits most of the visible light that we see. Above the photosphere is the chromosphere, which emits ultraviolet radiation, and the corona, which emits X-rays. The temperature of the outer layers of a star varies depending on its mass and age. As stars evolve, they undergo a complex set of physical processes that determine their fate. Most stars, including our Sun, will eventually exhaust their fuel and become white dwarfs, which are small, dense objects that emit very little light. More massive stars will end their lives in spectacular supernova explosions, which can produce neutron stars or black holes. Here are some additional points about the properties and structure of stars. Stars are composed mostly of hydrogen and helium, with trace amounts of heavier elements. These elements were created in the early universe by nuclear fusion reactions in the cores of stars. The mass of a star determines its evolution and eventual fate. Massive stars can live for only a few million years before exhausting their fuel and exploding as supernovae, while low-mass stars can live for trillions of years. The luminosity of a star is determined by its mass and age. More massive stars are brighter and have shorter lifespans, while less massive stars are dimmer and have longer lifespans. The temperature of a star is determined by its spectral type, with hotter stars emitting more blue light and cooler stars emitting more red light. Stars can have a range of surface features, including sunspots and prominences, which are caused by magnetic activity in the outer layers of the star. The interior of a star is divided into layers, with the innermost layer being the core, where nuclear fusion reactions take place. Above the core is the radiative zone, where energy is transported by radiation, and above that is the convective zone, where energy is transported by convection.